know that when we take a base and we react it with an acid, we get two products. What are those two products?
Water and salt.
Water and a salt. Good. So this is the one that we're going to be doing in the lab first today. We've got a base, which this time it's a hydroxide base. We know it could be an oxide base or a carbonate base. This time we're using a hydroxide base, and we're using sodium hydroxide. Where did that 1+ oxidation state come from? How did I know that? Periodic table, thank you. And OH is always a 1-, which is on your little sheet. So when I react those, I form NaOH. In these labs, this is called the titrant because it's what I have a known concentration of. And I'm reacting it with my acid. Hydrogen, again, is a 1+. Cl is a halogen, so it's a 1- oxidation state. So to be neutral overall, it's HCl. That's my titrant, which is an unknown concentration. And you were correct, we get a salt and a water. So my water is H2O. My salt is the Na with a 1+ oxidation state and the Cl with a 1- oxidation state. And if I look at this, I can see that it's already balanced. I have the exact same number of everything on either side. Aiden.
So salt is just salt is the other thing produced with an acid and a base reaction?
Exactly. That's the perfect definition for a salt. We could also throw in there the word ionic. It's an ionic substance formed from an acid and a base reactant. Good. This is the big equation that we're going to be using, and we see it based off of the fact that I have 1 mole of HCl and 1 mole of NaOH because it's already balanced. I have equal amounts of it. So I can use my concentration times my volume of the HCl being equal to the concentration times the volume of the NaOH because we learned a few days ago that the concentration is moles divided by liters. Moles divided by the concentration, and I know the moles there. So that's the equation that we're going to be using. This is our setup, and this is the part that you guys don't know how to use that we're going to be talking through. Yeah. First of all, these nice things that have been sitting out for you already are called burettes. Burettes are really expensive and very breakable, which is why we've been like, don't touch them. They're different too. If you take a look at yours right now, where is the 0? On the very top, not on the bottom, it's on the very top, and that is because we will be letting liquids out. We're going to be letting it out. So I read it differently than I read a normal graduated cylinder or something like that. So on this instance, I'm starting out with the 0 up here. I have 1 milliliter at this point, 2 milliliters at this point, and I've got tenths of milliliters in between. So if I look, I've got not up to 1 yet, I'm still at the 0. I've got 0.1, but I'm not up to the 0.2 yet, so I'm estimating my last digit there. That's my significant digit. It's, I think, at an 800th. Okay, maybe you think it's at a 900th. That's why your data and your lab partner's data are going to be different. So I put down that my initial volume is 0.18 milliliters, and then I add some of my liquid into my Erlenmeyer flask till I get to where I want to be. And in this instant, it's ended up being where my final volume is equal to 1.77 milliliters, because it's above the 1, it's above the 0.7, but it's not to the 0.8 yet. So I estimated, again, that last number. So the liquid is leaving and my volume is increasing. So I'm going to do a calculation where my volume added is equal to the volume final minus the volume initial, and we're not going to go through that right now. I've already done the cleaning out and getting ready process for the hydrochloric acid. You guys don't have one of those, but this is the more precise way to do it, so we're going to talk through it. And I have already measured out my VHCl, my volume of HCl, in my Erlenmeyer flask to equal 5.50 milliliters. So I've already got that measured in there. I also am going to need to add a little bit of phenolphthalein solution into my Erlenmeyer flask because I want to see when a change happens, when a color change happens. I'm just going to put 2 drops in there. Why is it colorless? Because it's an acid, thank you. It is an acid right now, so that part is good. I'm going to put that aside for now. Notice I've got everything listed here so I don't forget what anything is. So I have my titrant, which is my 0.1 mole per decimeter cubed of NaOH. I've got a graduated cylinder specifically for NaOH. I've got a funnel specifically for my NaOH, and then on the other side I have all the same stuff for the HCl of my unknown concentration, therefore my titrant. So I also have a few other items. This is called a burette clamp. I've got a little reading card for reading the meniscus so it's easier for me to see it. And I've got a white piece of paper that I'm going to keep under and behind this because we saw in the last lab it's hard sometimes to see when it turns pink. I want it just to be a very, very faint pink. So I have to clean this out. Again, I cleaned out the HCl one already. If you were watching while you were doing your other labs, you saw some of that. My burette has what's called a stopcock on the bottom. You might have a school where you don't have a stopcock and you have just a pinch clamp and a little dropper at the bottom. And you pinch it and the liquid comes out. In this case, if it is straight up and down, liquid should be coming through. So check your burettes right now. Make sure that it is not up and down because we don't want to start putting liquid in and having liquid come directly out right away. We want it so that it is horizontal. It's in the same level as the ground. And that's where we're going to start. So I want to get this cleaned out first. And I'm going to start by cleaning it with some deionized water, which I put into a squirt bottle here because it's easier for me to deal with. And I'm just going to squirt a few milliliters of water into this. Notice that I'm turning it. That turning is getting the liquid on all sides. And I've got my waste container here. I didn't even add probably 3 milliliters. I just added a little bit to it. I'm going to allow some of the water to exit out the bottom, and then I'm going to close it back up. And then I'm going to swirl as I allow all of the water to exit the top of the burette into the waste container. So I'm just cleaning it out. I don't know who used this burette before. I don't know what they were using, so I don't want their stuff in there. Hopefully they cleaned it out before, but you never know how well they cleaned it out. So I've got most of the water out. I'm going to do one more open down here just to make sure I get all of what's in there out. And now I'm going to clean with some NaOH. So I'm going to put this here for safekeeping while I get my NaOH, my Titrant, my 0.1 mole per decimeters cubed of NaOH. And I'm going to pour like 3 to 5 milliliters into my graduated cylinder, being sure that I'm measuring from the bottom of the meniscus. Oops, and I spilled over a little bit right there. Good. So I've got 4 milliliters that I'm going to put into my burette right off the start of my NaOH. And I've got a little funnel, and we know from gas laws that if I just allow my funnel to sit in here and there's no place for the air to go, the liquid's going to stay in the top of the funnel and start going out over the top. Luckily, I'm only dealing with 4 milliliters right now, but it could be much worse if I'm trying to pour more in. So what you're going to want to do is kind of hold the funnel up a little bit so that air can go in and out as you're pouring it in. And I'm just going to pour very carefully my NaOH into my burette. Again, I made sure that it was closed at the bottom before I started this because I don't want to cover the floor in NaOH. So put that aside, and I'm going to do the same process that I did with the wastewater. So I'm going to let a little bit of this out first. So I'm coating the inside of it with NaOH. Tapping it a little bit, see if I can get any drops off before I take it out of the way. And then I'm going to swirl very slowly so that it coats all of the sides on the inside of the burette before it goes out the top into the waste container. Now that NaOH is not exactly 0.1 mole per decimeters cubed because there was some water still stuck to the sides of the burette. That's why I want to make sure that I get it out. I've got the water part out now because I used the NaOH to get that out. Okay. Next, I want to fill this entire burette with NaOH, or at least most of the way to the top. It doesn't have to be exactly to the top because we know how to read it. It could be almost to the top. It's okay. Or if you know you're not going to need much, you could just fill in a couple milliliters at the bottom. So I'm going to use my funnel again. Notice that I'm not filling this above my head. I'm not leaving it up here. I've taken it off and I'm holding it down so I can see what's going on with it. I double check that the bottom of it is closed. And then this is the part where I'm going to be watching a whole bunch of stuff right now. Holding it up ever so slightly. I'm going to be watching to make sure I don't overfill here. And again, I check to make sure that it was closed at the bottom. Now, if you happen to overfill, so you go above the 0.00 milliliter line, you can just release some of it, whatever is at the top over an excess, into the waste container. Now, multiple trials are going to be your friend with this. You want to get the most accurate thing possible. And we generally start out with a kind of waste example first. We don't want to be too precise with the first one because we want to get an idea of where we turn pink, but it's okay to over titrate, so to add too much of it the first time. Okay, I'm going to place my Erlenmeyer flask under the tip of the burette. I'm going to start slowly allowing base into it. I'm not doing it too slowly right now. Notice it's turning pink. Once it starts turning pink, we want to slow up the drip of it. And we're going to keep swirling until we get a very faint pink overall. Again, I would over titrate my first one to figure out how much I had. I started at exactly 0.00 on this one when I filled up my burette, so I would have written that information down. I'm going to break the burette tip, so I'm going to move it to the side. And it looks like it went back to colorless, so I'm going to need just a few more drops to get it back to the NaOH being slightly in excess. Okay, this one I got a few too many extra drops in it. So this would be a good first one. I would look at my volume, and I'm not going to tell you what it is because I don't want you to have a clue as to what you're going to need to do. But I would see that, and I would base my next two trials off of that. And those next two trials are the ones I would use for my calculations. Now, if I did go just a little too far and I wanted to go back to colorless, I would take this over to the HCl one. I would record my initial volume. I would add enough HCl to get it either to that beautiful light, almost colorless pink, or if I wanted to go completely to colorless, I could, and then add that one more drop of NaOH to hopefully get it to a very faint pink. I would record the total amounts of NaOH and HCl that I started with and that I ended with, and I would use those for my calculations of my volume HCl, volume NaOH. Did about 2 drops of NaOH on that one, and it looks like it was just ever so slightly too much. I probably should have done just 1. But you're going to be doing this process over and over again. You don't need to continue to re-clean it each time. You now know what's in it and you're not changing what you've got. When you are totally done with the experiment, you can put all of your base back into the base beaker and all of the acid back into the acid beaker. And then whatever is in your Erlenmeyer flask gets put in the waste container. You can wash it out and then wash it with the deionized water. You'll want to wash with deionized water when you're done with this because, again, we don't want to keep any materials in it and we don't want to make things harder for the next group that comes in to do a titration. What questions do you have? Good, Siri.
What is the goal of this experiment?
We are looking for the concentration of HCl. Good question. There's lots of directions in your direction book. You will not do the step where you're going to HCl. We're just going to do the one with NaOH. We are going to look at the very end of the experiment to see who's got the lightest pink. So when you've got a really faint pink, you can call Mara and I over. And when you finish your calculations, you're going to turn your calculations in. Again, as a group, and you've got 2 to 3 people in your group, you can do multiple trials so that you get the best answers to get the best solution. And that's one of our competitions here, Michelle.
For the first one,
Yeah.
since we don't have a lot of urets for the acid,
Yeah.
we just dump it out after we're done.
Yep, you would put it in the waste and then you would start with the next one.
Start us over.
Exactly, yep. Other questions? Awesome. So read the directions very carefully. That just went through the washing process, so you now know how to wash them. Again, we're not doing the acid.